Okay, for question 13, I'd do a little rewrite here and use rational exponents rather than a radical. So this would be x squared minus 1 raised to a power of 1/3. Now to find the derivative is going to be another chain rule. We have an outer function that's something being raised to the 1/3 power. So let's take care of that. We drop down the power and then decrease the power by 1. And then we take the derivative of the inside function, which is 2x. Okay, now we don't want to have negative exponents. So this term right here, x squared minus 1 to the negative 2/3, is going to drop down to the bottom of the fraction along with the 3. This 2x is going to stay on the numerator, so we have 2x divided by 3 times the cube root of x squared minus 1 squared. Now you can either write it like that with radicals, or if you just want to keep it with a rational exponent, you can write it as x squared minus 1 raised to the 2/3 power. Either would be fine. Okay, question 14 is a product rule. It's x squared times x minus 1 to the 5th power. And then it's also going to include a little bit of a chain rule here. So if we have an h and a g function, remember the product rule is h prime times g plus h times g prime. So taking the derivative of the first part of the function would be 2x times the g function, x minus 1 to the 5th. Now we add x squared times the derivative of the g function, which is going to be 5 times x minus 1 to the 4th power, then the chain rule times the derivative of the inside function. So simplifying here, we get 2x times x minus 1 to the 5th plus 5x squared times x minus 1 to the 4th. Now looking at this term compared to this term, they both have an x in common and an x minus 1 to the 4th power. So factoring out a common factor of x times x minus 1 to the 4th power, if that's factored out of this first term, that's going to leave 2 and then an x minus 1. And then if this is factored out of this, if our common factor is factored out of the second term, that's going to leave a 5x. Okay. And then 2 times the quantity x minus 1, that's just 2x minus 2. Combining like terms inside the parenthesis there, we're going to have x times x minus 1 to the 4th times 7x minus 2. Okay, so for question 15, a higher order derivative, it's just a derivative of a derivative of a derivative in this case. So to find the first derivative, that's going to be 6x plus 7. Okay, the second derivative is the derivative of the first derivative, which is going to be 6. And then the third derivative is the derivative of a constant, which is 0. Okay. Question 16. It's still from section 2.6. It's talking about a higher order derivative because we're going to have to find an acceleration function. The position function. So we have a 30-foot platform. That's the initial height, initial velocity of positive 5 feet per second. So the position function is negative 16t squared plus 5t plus 30. Now how long will it take for the diver to hit the water? This is much like the question on this review from before with the object being thrown off of a cliff. So we need to solve for when s of t is equal to 0. So that's going to be 0 equals negative 16 t squared plus 5t plus 30. So if we do the quadratic formula, this doesn't factor, so we're going to have to do the quadratic formula. T is going to equal negative 5 plus or minus the square root of 1,945 all over 2 times A. Now, just like before, it's not going to make sense to have a plus and a minus. This is a value of time, which has to be positive in this situation. And because we're dividing by negative 32, that means our numerator has to be negative. So I'm going to take the negative 5 minus the square root of 1945 over negative 32. This is going to turn out to be a positive value. And this is when the diver hits the water. This is how long it takes. Now, the diver's velocity at impact. The velocity function is the derivative of the position function, so that's going to be negative 32t plus 5. So the velocity at impact is negative 32 multiplied by this value of time right here. Plus 5. So the negative 32 cancels here. So it's going to be, and then the negative and the positive 5 will cancel. So it would be negative 1,945 feet per second. And again, it makes sense that the velocity is negative because the diver is traveling towards the water. Now the diver's acceleration is the derivative of the velocity. That's going to be equal to negative 32 feet per second squared. Okay, so 2.7 implicit differentiation. What we do is we take the derivative of this entire equation with respect to x. So the derivative of y squared is 2y, but since we're taking the derivative with respect to x, we have to do a chain rule with y, because y represents a function of x. So we did an outer function, which is 2y, and we multiply that by dy dx. That's the derivative of y with respect to x. Plus 2x minus 6 dy dx minus 2 is equal to 0. So that's the derivative with respect to x. Now we have to get dy dx isolated. So we need to move all the terms that do not have a dy dx factor to the right side. So it's going to be 2y dy dx minus 6 dy dx equals negative 2x plus 2. And then on the left side, both terms have a dy dx, so you can factor out a dy dx. You get 2y minus 6 equals 2 minus 2x. And then divide by the 2y minus 6. So the derivative with respect to x is equal to 2 minus 2x over 2y minus 6. It's a similar situation here. This one is a bit more complicated because we have some product rules here. But in this case, we have a product rule. So the derivative of this first term, 2y squared, is 4y dy dx. Now with this second term here, you can think about this as two different functions. We have an f and a g function, so we have to do the product rule. It's going to be f prime, so that's 8x times g plus the f function times g prime. And then we have the same situation here. So we have an f and a g function. So we have to subtract this expansion. Notice how I'm doing this in parentheses because we're subtracting this product rule. So it's f prime, which is 3 times g plus f times g prime. So it's 2y dy dx, and that's equal to 0 because the derivative of 4 is equal to 0. So distributing the minus sign here, we just get rid of the parentheses and change that to a negative. And then it's a similar situation as the problem above. We need to get all the dy dx terms on the same side. So this is going to be 4y dy dx plus 4x squared dy dx minus 3x2y dy dx. These are all the terms that have a dy dx factor. On the right side, we're going to have a positive 3y squared minus 8xy. And then we factor out a dy dx. We're going to have 4y plus 4x squared minus 3x2y equals 3y squared minus 8xy. And then dividing by this term is going to give us dy over dx equals 3y squared minus 8xy over 4y plus 4x squared minus 3x times 2y. Now 3 times 2, that just becomes a 6, so it's 6xy.